Good morning, students. On today's lecture, I'll cover the magic of the supplementary angles in trigonometry, the second and final part of it. Okay. In my last video, I showed you this parental graph of sin x and cos x and tan x. And you have seen that sin is positive in the first quadrant and second quadrant, cos is positive in the first quadrant and the fourth quadrant, and tan is positive in the first quadrant and third quadrant. And we did something like this. It's a quadrant I have drawn like that, and I said here all positive and here only sin positive and here only tan positive and here cos positive, which means here sin positive, then cos positive, here cos negative in the second quadrant, in the third quadrant cos negative, and the fourth quadrant cos positive. And in the first quadrant tan positive, in the second quadrant tan negative, tan positive over here, and sin negative in the third quadrant, and here in the fourth quadrant tan negative and sin negative. Okay, I hope you remember all students took chemistry. Okay, to just give you a quick overview on the graph, you can see that sine graph goes like this, and from 0 to 180 degree, that means first quadrant and second quadrant, the graph lies above the x-axis, therefore y is positive. Over here sine is positive in the first quadrant and the second quadrant, and from third to fourth, that means 180 to 270, that's third quadrant, 270 to 360, the graph lies below the x-axis, therefore y is negative, or sine is negative in the third quadrant and fourth quadrant. For the cos, you can see that 0 to 90 degree, cos theta is above the x-axis, and 270 to 360 above the x-axis. So third and fourth quadrant, first and fourth quadrant, first cos positive and fourth cos positive. And in between 90 to 270, where third and fourth, second and third quadrant lies, this graph is below the x-axis, therefore this is minus. So cos is negative in the second quadrant, cos is negative in the third quadrant. Tan positive in the first quadrant, 0 to 90, you can see that it's above the x-axis, and over here 180 to 270, that's also above the x-axis. So this first quadrant and the third quadrant, tan is above the x-axis, it's positive, and 90 to 180 and 270 to 360, that means second quadrant and the fourth quadrant, tan is below the x-axis, therefore this is negative. So we prove that. Now we are ready to see what magic the supplementary angles do in trigonometry. Okay, now let's do sine theta equal to, let's have it 0.5, because in my last video I have showed that y equal to 0.5, I take this value, so I'm gonna keep 0.5 as well in this video. Now theta, let's find out where this 0.5 we can get in the sine graph. We have proved that it's in 30 degree and 150 degree. Let's do it again. Sine inverse, then 0.5, I have 30 degree. So this is 30 degree. Okay. Another one, I'm gonna say that, see, sine is positive. This is positive value. This value is positive. This value is positive. And positive value in the first and second quadrant for sine theta. So I already calculated, since this is an acute, most of the time it's going to give me acute angle. Now since it's an acute angle calculated value is acute angle, and I got that 30 degree. Another one has to be 180 minus 30, that's supposed to be 150 degree. 150 degree. So we write down this formula such as this: sine theta equal to sine 180 minus theta. Okay, so sine theta acute angle, that's 30 degree, so that's gonna give me 0.5, and sine 180 minus 30, that's gonna give me 150, that's also 0.5. Now we're gonna go for the same value, 0.5 for cos theta, 0.5, and theta. I'm gonna use the calculator again, shift cos, that's gonna give me cos inverse 0.5, that's gonna give me 60 degree. Okay, let me write down that cos theta equal to cos, let's say 180 minus theta. So this theta is 60 calculated value, and when I put this value over here, then I got on my right hand side cos 180 minus 60, that's 120. So let's put 120 here. Now I have a problem. According to my graph, cos is negative in the second quadrant, 90 to 180. According to this one, it also shows cos is negative, but over here I did 120, which lies in between 90 and 180. This is in the second quadrant. In second quadrant, this value is supposed to be negative, and over here is positive. So I have written cos something positive equal to cos something negative. Okay, let's see that. Cos 120, that's negative 0.5. So it's same value, but with negative sign. Now we got a problem, right? So what can we do to fix this problem? This whole thing is gonna give me the same value 0.5 with negative sign. So as soon as I introduce a negative sign over here, then my equation left hand side and right hand side is equal. Watch, negative cos 120. So negative cos 180 minus 60, that's 120. That's gonna give me 0.5. So this is okay. All right, so we rewrite this formula, this equation, cos theta equal to cos minus cos 180 minus theta. Let's see what happens if I have tan theta. Tan theta, we're going to write down again same way, tan 180 minus theta. Now, this is in the second quadrant, right? 180 minus theta is over here. And let's say tan theta be 0.5 again. So theta equal to tan inverse 0.5, I got about 26.6 degree. Okay, and then when I subtracted that from 180 minus that, I'm getting 153.4 degree. Okay, same thing. Now tan 26.6 is 0.55, that means that one. So this is okay for this value. And whenever I have that, tan 153.4, that gives me again 0.5 with negative sign. So same as before, I'm going to introduce a negative sign over here. So this value is not correct and this value is not correct. We have to find some other way of doing this. Okay, this is okay if I do it this way. Okay, but see, cos is positive over here. Okay, and cos is positive, another positive value I'm gonna have in the fourth quadrant. So what are you gonna do? We're gonna go all the way from here. Okay, let me draw a graph over, sketch a graph over here. Sine is positive, so this is gonna be 30 degree, and then another one I'm gonna reflect this over here. So this is 30 degree, so I need this value, and that value is 180 minus 30. That's gonna be 150. Okay, so that value is here. So this one is okay, this one is okay. For cos, I have positive here, that's 60 degree, and another one in the fourth quadrant, so somewhere over here. So this is negative 60 and I need positive value, so I'm gonna go from here to here. So this value is gonna be all the way 360 minus 60 degrees. So 360 minus 60, that's gonna be 300. Now let's see, cos 300, that gives me half. So instead of that, I'm gonna put 300. Okay, now for the tan, so I'm gonna draw the graph again. So the first is over here and that's 26.6. Okay, now tan is positive again in the third quadrant, so this should be somewhere over here. Okay, and this angle should be 180, this 26, this is 26.6, plus 26.6. So that's going to be 180 plus 26.6. That's going to give me 206.6, not that. So instead of that, I'm going to write down that. So 10 to, let me do with the first one. 10, 26.6, that gives me 0.500. And for this one, 10, 206.6. And that's also 0.500, and the rest of the values, because I take the average, I take correct to the 1 decimal place, I rounded it off, I didn't take all values. That's why I have some discrepancy over here. Okay, so that's what it is. Now in my next few videos, I'll solve some of the trigonometric functions like this, but today I'm going to talk about something else related to that. Okay, that lot of students ask question. Okay, but why I was saying that the magic of supplementary angles in trigonometry. Now remember, in my first video I said cos theta equal to sine 90 minus theta, and then sine theta equal to cos 90 minus theta, and tan theta equal to cot 90 minus theta. And I call this one magic of complementary angles, because whenever you add these two angles, that always becomes 90 degree. Theta plus 90 minus theta, theta cross out, so it's 90. And theta 90 minus theta over here also complementary, over here also complementary. So in complement, when we have complementary angles such as this, so sine 90 complement of theta becomes cos, cos complement of theta becomes sine, cot complement of theta becomes tan. But whenever we have supplementary angles, watch this, this theta and this 180, that together is supplementary angles. Okay, and this two supplementary angles, these two supplementary angles, and when sine theta, and I have supplementary of this theta, that sine remains sine, cos remains cos, tan remains cos, tan remains tan. Now only difference is for the cos and tan, they changes their sign. So this is the beauty of supplementary angles in trigonometry. Now the last one that I really want to talk about is, some of my students always ask me this question: why do we add or subtract from 180 degree or 360 degree? Okay, why not 90 and 270? I'll just show some of that. Let's say sine, I'm gonna go through that example again. Sine theta equal to 0.5. I hope you remember that whenever I write down this theta, okay, so it's always oppo over 1. That's in unit circle, you have seen that hypotenuse we have taken as 1. Okay, so this is nothing but sine theta, and this is our cos theta, right? Okay, now what happened if this theta, we already find out theta equal to 30 degree. Okay, the first value in the first quadrant. So I'm gonna just draw this Cartesian axis over here. This is x, this is y. Now this is my h1, this one be h1. Okay, and another value, what I talked about is when I reflected that on y-axis. Okay, then I'm gonna use this blue color, that when I reflect that, this triangle is gonna come to this particular place. Okay, so that's theta equal to this theta, that one is 1, and this let it be h3. Okay, so this is how we did that, and this one was 180 minus theta. That's actually accepted way, the way we have done, the way I told you all these videos. Okay, but instead of taking 180 minus theta, what happened if we add with 90 plus theta? That this falls in the, since this is acute, this falls in the second quadrant, this also falls in second quadrant. But what happened if we do that? Now when we do that, let me draw this one again. So that triangle here theta, and that's my h1, it was 0.5 sine theta was 0.5, so that's 0.5, and this is 1. Now when 90 plus that, so 90 plus this, that triangle becomes something like this. This, okay, this, and 90 plus theta, this theta comes over here, that's 1, remains same, and let it be, that's h2. Okay, now according to this, okay, nothing wrong with this. If I do this one opposite of that, that's gonna be 0.5. Okay, nothing wrong with that. But problem here is, this is the height. I wrote down this is h2, but this is not height. Height over here is this part. This part is the height. You remember that when I rotate that anti-clockwise, then this is the height. Red pen is height. So it keeps going on and on and on and on and on and on, and that coincide with this vertical line. And when it falls this way, it becomes smaller, 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 smaller. So the height should be somewhere over here. This is not the height. So this is not what we are looking for. So if you think this is the height, let's say this is h3. Okay. Now if it's h3, this is not gonna be theta. This is gonna be 90 minus theta. Okay. So in this case, it was 30. So if this is 30 and this is 30, automatically this is going to be 60. Why this is 60? Because this is a 90 degree complementary angle. So this is 30, this is 60, makes 90 degree. Now this one is sine, this h3 equal to sine 60 degree. Now whenever we have sine 60 degree, sine 60 gives me root 3 by 2, or if I take 3 decimal places, it's going to be 0.866. This is this height, and this height initially was 0.5. That's way bigger than h1, which one was 0.5. So this value is not accepted. Now if I take this one, okay, and if this I make this one 150, okay, it comes to 150. So when it comes to 150, watch, sine 150, that's nothing but half, or 0.5. This is 0.5. So instead of 90 plus theta, so this is wrong, we just check that, it has to be 180 minus theta. Now let's talk about in the third quadrant, if I can do this 270 plus theta or minus theta. Okay, so again in this case, let's say sine theta equal to negative 0.5. so sine inverse negative 0.5, that's gonna give me theta, gonna give me minus 30 degree. Okay, so where is minus 30 degree? You know that anti-clockwise, that's gonna be my minus 30 degree. It's somewhere over here. That's minus 30. So therefore, well, minus 30 is in this side, so I can put positive, and this is h1, and that's negative 0.5, because this is the height, the value of y in Cartesian form below the x-axis, that's negative, and this is 1. Okay, now if I just reflect that over here, the graph is going to be looking something like that, and then this theta is this theta over here. So this one, nothing but this angle is going to be 180 plus 30, that's going to give me 210 degree. Okay, so let's see that. Sine minus, I'm going to put the bracket, minus 30 degree. So I have negative half, that's negative half, and sine 210, that's also give me minus 0.5 or negative half. So that's half, minus half, that's minus half as well. Now if instead of this 180 plus 30, if I do 270 minus 30, that means I'm gonna go all the way from here to here, 270, and subtract this 2 over here. Then I got something like this. This is 30, okay, and then this is my 1, this is h3. I don't need to do any calculation. You can see that if I do this, that gives me h3. That's gonna be okay. That's gonna be negative 0.5. But again, similarly, this case over here, that's not gonna be height. That's gonna be distance from the origin over here. Okay, how far this radius move from the origin over here or from over here. This is not the height. Height is this one. So same case, height is this one, not this one. This is not height. Height is this one. Therefore, we cannot take it like that. If 270 minus 30, that's going to be 240. Try to put that in sine. Sine 240, that's going to give me minus 0.866. And this is minus 0.866, way bigger than minus 0.5. So it's not only magic of complementary angles or magic of supplementary angles. The formula goes like that. Okay, sine 90 minus theta becomes sine theta, complementary angles. I'm going to write down again. Cos 90 minus theta becomes cos theta. Tan 90 minus theta, that becomes cot theta. Okay, and for supplementary angle, sine 180 minus theta, that becomes sine theta. Cos 180 minus theta, I know that's in the second quadrant, this is negative value, so I can write down this is going to be negative cos theta. I am just rewriting that formula. And tan 180 minus theta equal to minus tan theta. So magic of complementary angles, magic of supplementary angles. But then we can do this as well. Okay, I should have done this over here, but that's okay. Sine theta equal to sine 360 plus theta, if theta is positive, if sine theta equal to positive. Okay, then this is also going to be positive. You can see that it goes all the way to 1 revolution, and theta acute, it fall in the first quadrant again, so that's going to be positive. Cos theta, if this is positive, then cos 360 minus theta. Tan theta, if this is positive, all this theta, all this sine theta, cos theta and tan theta, if all of them are positive, all of these are positive, sine theta positive, cos theta positive, tan theta positive, then this is going to be tan 360 plus theta. Okay, if sine theta, cos theta and tan theta are negative, then sine theta equal to sine 360 minus theta. Now this is negative, so it's going to be negative over here. Then cos theta, since it's negative, then I cannot put that in the fourth quadrant, because this is the fourth quadrant, so it's not going to be valid over here. So this is, I leave it empty. Tan theta, negative tan theta, is going to be tan 360 minus theta. This is in the fourth quadrant, negative, so this is that. So whenever you have any 90-degree angle with some value of, let's say, m, and if m is positive, okay, then sine, not positive, sorry, even, if it's even, then sine remains sine, cos remains cos, tan remains tan, but be careful with the sign, because where they fall into, in the first quadrant, second quadrant, third quadrant or fourth quadrant, it just changes. But if 90 times m and this m is odd, okay, then we have to be very careful, because it doesn't give the height. Why did I do that? I think it's over here. Yeah, it doesn't give the height. It just show the displacement, or how far is it off from the origin. Okay, so be careful with that. And lastly, very lastly, I'm gonna give you some negative angles formula. Okay, not formula, it's just the way it is. Okay, sine negative theta is always negative sine theta. Cos negative theta equal to cos theta, and tan negative theta equal to negative tan theta. Now what is negative theta? Negative theta is, instead of going clockwise, anti-clockwise, if this line moves clockwise, so if it moves clockwise, then this is negative theta, and you know that negative sine theta is going to be negative sine theta because it's in the fourth quadrant. Tan is negative as well in the fourth quadrant. Only cos is positive, so even though cos negative theta, it's always cos theta positive. Okay, I hope you enjoy this magic of the supplementary angles in trigonometry. If you have any question, leave a comment. I'm gonna do some of the math in my next video. Okay, all right, see you guys, take care, have a good day.